Chi-square test. Chi-square test was developed by Carl Pearson in 1900. It is a non-parametric test because it is not based on or consider any assumption or characteristic of the population. It is also called distribution-free test. As it is a non-parametric test, so normality of data is also not required here. Chi-square test is used to measure the differences between the observed and expected datasets. It is based on frequencies and not on the parameters like mean and standard deviation. As you know very well that in parametric statistics we need mean and standard deviation, but in non-parametric test we need categorical variables. So to run chi-square we need data in terms of frequencies. Chi-square test is widely used in different type of researches related to business field, related to health studies, and any marketing research. So it is widely used because it can be applied to a complex contingency tables where several classes are present. So it helps the researcher to do the work with very ease because there is no complex mathematical calculation required in the chi-square test. Contingency tables. What are contingency tables? Contingency tables are also called crosstabs or two-way tables in which the values of the two variables are present simultaneously and it is easy to compare one against the other. Now, how in different settings the applications or types of the chi-squares, the function it serves are three: goodness of fit of distributions, test of independence of attributes, and as a test of homogeneity. What does it mean when we say goodness of fit? As a goodness of fit test, chi-square enables to see how well does the assumed theoretical distribution fit to the observed dataset. When the calculated value of chi-square is less than the table value at certain level of significance, the fit is considered good, and if calculated value is greater than the table value, the fit is not considered as the good. In some statistical analysis, chi-square report as a test of the goodness of fit, that the sets of data, they are very well adjusted with each other at certain level of significance. Whether we have set level of significance at 0.05 or 0.01, so according to the certain level of significance, how data is can be matched with the theoretical distribution or assumed distribution. Sometimes it used as a test of independence of attributes. As a test of independence of attribute, it enables us to explain whether or not two attributes or two characteristics are associated with each other. For example, uh, if a new medicine is developed for any disease, nowadays we are searching of a medicine for COVID-19. You can take example of it. When some medicine is made, that researcher or health professional has some assumptions about the effects of the test, has some expectations from the results or of the medicine. So it assume action of medicine is calculated by using the medicine on some subjects, that what are the situation of the two sets of data. One is the expected action of medicine, and what second set is what medicine actually doing when it is using. So in these type of researches, chi-square is applied because it gives clear and easy to calculate method, so it gives answer quickly and clearly. Testing independence determines whether two or more observations across two variables are dependent on each other. If the calculated value is less than the table value at certain level of significance for a given degree of freedom, we conclude that null hypothesis stands or null hypothesis accepted, which means that two attributes are independent or not associated. And if calculated value is greater than the table value, then we reject the null hypothesis. So it is the same situation as that when our calculated value is greater than the critical value written in the table, then we reject the null hypothesis and we accept the research hypothesis. That difference exists. As a test of homogeneity, chi-square also used to test whether the occurrence of events follow uniformity or not. If sometimes it is also used to measure the uniformity of the events. For example, if someone is interested to measure that in government hospitals same number of patients come all the weekdays, so it can be tested with the help of chi-square test. Here is the formula of the chi-square: sigma sum of, it is Fe expected frequency minus observed frequency divided by expected frequency. As I explained told earlier, that in chi-square we need data set in frequencies. So symbol is also indicating the same. What are the steps to perform chi-square test? Just like all statistical analysis, first we have to state null hypothesis, our alternative hypothesis. We select level of significance or alpha level. We will find critical value in the table. Then we calculate the test statistics and then we draw conclusion. Here we have a problem. There is no effect of punishment to crime, and the alternative hypothesis is punishment reduce crime rate. It is the data set in which we have 6 sets of data which are in frequency 22, 24, 38, 30, 46 and 44. Now here is the same data which I showed you on the previous slide. Now first we have to calculate the expected values from this observed data set. How the expected value calculated? Expected value calculated from this formula, total of observed values multiply by 1 divided by 6, or observation divided by total number of observations. Here 6 is written if, because we have 6 set of observation in our observed data set. Is it clear to you all? 1, 2, 3, 4, 5, 6. So that's why we have written 6 here. If we have 10 observations here, we write 10 here. If we have 15 or 20 here, so it will be 6 will be replaced by that number. Now the total number of observed values, that these are the observed values, so first we make them total. Total came out 204. So we write it here 204, total of observed values, and in the other bracket 1 upon 6 will remain as it is. 1 divided with 6, answer will come 0.166 multiplied by 204 as 204 multiply 1 divided by 6. So it is the simplified version. And when we multiply these two values, we get the answer 34. Now you must observing here that the expected values is same, because we have only one expectation, that the maximum performance of the subjects, or maximum uh, response will be go up to 34. So it will be just like a constant number now for whole data set. And why expected one value is same total number divided by multiply by 1 into 6. Similarly, if we calculate the other second expected value, the resultant will be the same because nothing is changing. What we need, total of observed values multiplied by 1 divided by 6, or 1 observation divided by total number of observation. So it remains constant here, it also remains same here. So we always get the same answer. So that's why we make this table from the help of observed data, and we set our table here. So it is the expected data set and it is the observed data set. Now how to calculate the level of significance for this problem set taken is 0.05. What is 0.05 mean? It means that there are only 5% chances, otherwise 95% we would have confidence on our value. Now the formula is written here, which I showed you earlier, and now we place the values here. Observed frequency, we have 6 set of scores: 22, 24, 38, 34, 30, 44 and 46. So one by one we place the values. Observed frequency 22 minus, we know expected frequency is constant 34, whole square divided by again expected frequency 34, plus second set data set value 24 minus observed frequency 24 minus 34 whole square divided by 34 expected frequency, plus now the third value 38 minus 34 whole square divided by 34. So similarly we put all the data here to get a sigma of all these values. Now simplify the problem. 22 minus 34 is equal to 12. 12 whole square divided by 34. So this whole equation is simplified as 12 whole square divided by 34 plus, now the second value, 24 minus 34, answer would be 10. 10 whole square divided by 34 plus 38 minus 34, it is 4. 4 whole square divided by 34 plus 30 minus 34, answer is again 4 divided by 34 plus 46 minus 34. So we get the answer 12 whole square divided by 34, and in this way we simplify all the values. Now whole square means 12. Whenever any value is in whole square, you have to multiply it twice. 12 multiplied by 12 is equal to 144 divided by 34. 10 multiplied by 10 is equal to 100. 4 multiplied by 4 is equal to 16. Again 4 multiplied by 4 is equal to 16, and similarly we get all these values. After dividing these values with 34 denominator, we get the answer 4.23. Then second answer came 2.94. Third answer came 0.47. Again 0.47. Then 4.23. And then 2.94. When we add all these values, we will get our answer, that is 15.28. Now what we have to do, as you know, that after calculating our statistical value, we go to the table of chi-square test, and there we look at under the level of significance 0.05, that what is the answer, what is the critical value written there, and that critical value which was written there was quite smaller than the level, the value we calculated from this problem, from this data set. That's why we reject the null hypothesis, and we write our conclusion that the statistical value of the chi-square is significant at greater than 0.05 level of significance. Thus, null hypothesis rejected and alternate hypothesis accepted. And null hypothesis rejected, that there is no effect of punishment on crime rate, but our alternate hypothesis, that there is an effect of punishment on number of crimes. So in this way we calculate and we present our results. Keep it remember that to observe the chi-square we have the set of tables, similarly as we have for the correlation and t-test and ANOVA and regression, where we will check that our calculated value, whether it is meeting the level of significance. Here as we take mine 0.05 level, so whether our value is greater than the critical value written in the table or it is less than. Our calculated value was greater than the critical value written in the table. That's why we reject the null hypothesis and we accept the alternative hypothesis. For any other query, you can ask any question. And I also have send you data to calculate the Start there by yourself to make some practice. So keep learning, and if any query, you are welcome. Thanks.